We are discussing about matrices and determinants. What are these? Different properties and examples. So, what are we going to see is the meaning of matrix, then the different type of matrices. Please remember, matrices is just the plural form of matrix. Matrix means one matrix, one plus matrix is matrices. Transpose of matrix we'll see, and what is symmetric and skew symmetric, minors and cofactors we'll see, and the computation of adjoint and inverse of matrices. Types of matrices. Since matrix is just a form of rows and columns, that is the arrangement of numbers, values, content in the form of rows and columns are known as or is known as matrices. Okay, so just remember table whenever you are talking about matrices, because matrix are nothing but a table in the form of rows and columns. The number are arranged. So there can be different types of matrices. It depends on how the formation of table is. What are the contents inside the table is. The first one is a rectangular matrix. The rectangular is the rows and the columns. That is the horizontal and the vertical. These, the rows and columns are not same, because number of rows I am writing n, number of columns I am writing m. So this is the order of the matrix or the dimension of matrix. When this n is not equal to m, they are not similar, they are not same. This is the row, this is the column. So when the rows and columns are unequal, then we call this kind of matrix as the rectangular matrix. So we have two rows here, one, two, three columns here. So you can very well write the dimension or the order 2 into 3. That is, they are not same. This is a rectangular matrix. Now, square matrix is a special form of rectangular matrix where the row and column are same. That is, if n is equal to m, then we call this matrix as square matrix. So you see 1 to 3 rows, 1 to 3 column. So we have 3 rows and 3 columns. So that is why it is a square matrix. Square matrix, all sides are equal. A square is a shape with all sides equal. Now, coming to the diagonal matrix. Okay. So when we draw this diagonal matrix has to be talked with the square matrix. So when we draw a diagonal in a square, all the elements which are coming onto that diagonal, those values are we are interested in. So diagonal matrix means all the values on the diagonal will have some value, otherwise it will not be. Rectangular matrix cannot have a diagonal. Okay, I showed you there will not be any diagonal. So in diagonal matrix, all the elements which are coming on the diagonal should have certain value. Other values should be 0 or will be 0. Okay. So this matrix I'm writing 2 0 0. Then this have to be 0. This is 4. This is 0 0 0 7. And now let me draw the diagonal. And this diagonal, all the values on the diagonal are numbers. Others are 0. That is why we call it as a diagonal matrix. Now, scalar matrix. Scalar matrix is a special type of diagonal matrix where the diagonal elements are same. All other elements are 0, the diagonals have some value, and all these values are same. They are exactly same. This is called the scalar matrix. So let me write one more scalar matrix for you apart from this example. Minus 10, 0, 0, 0, negative 10, 0, 0, 0, negative 10. So when you see this diagonal, all the values are negative 10. That means this is a scalar matrix. Row matrix. Now a matrix is consisting of rows and column, and the order can be written as n into m. So when we have a matrix with only one row, single row, we start calling that matrix as a row matrix. Only one row, row matrix. So the row we have fixed. When the row is fixed as 1, if I call n cross m matrix, n is 1 here. Now, if we take a different view, the matrix can have only column without any row. Number of rows can be there, but columns is fixed. So when column is fixed, we call the we'll start calling that matrix as column matrix. So row matrix, only one row. So when we say n cross m, n should always be 1. That is a row matrix. Column matrix, n cross m, the m should always be 1. Column should always be 1. This is a column matrix. Identity matrix. Now this is a special type of matrix, square matrix, with all the diagonal element should be 1. Should be 1. This is also a scalar matrix. Identity matrix is a scalar matrix also. It's a diagonal matrix. But it is a special kind of diagonal matrix where all the elements in the diagonal is 1. I'm making a 3 by 3 matrix. The example this shown is 2 by 2. I'm making 3 by 3. So 1 0 0 0 1 0 0 0 1. So you see all the diagonal elements are 1. And when you have all the diagonal element 1, other values are 0, then we start calling it as the identity matrix. Okay, this is the identity matrix. Okay, coming to the zero matrix. Zero matrix means, as the name suggests, all the elements has to be 0. That is, there will be no element other than 0. It can be 1 by 1 matrix, 2 by 2 matrix, or 3 by 3 matrix. So I'm making a 3 by 3 zero matrix. All elements, 3 rows, 3 columns, all elements are 0. This is a zero matrix. Upper triangular matrix and lower triangular matrix. Now the main thing comes here is the diagonal. Whenever we talk about upper and lower, it has to be first of all square matrix. Then only you will get a diagonal. And diagonal, the lower part and upper part, that decides it's a upper triangular matrix or lower triangular matrix. Upper triangular matrix, all the elements above and including the diagonal should be having some value, others should be 0. That is, the upper part has some value, lower is 0. In the lower triangular matrix, the lower part will have certain value, this diagonal including, but the upper part will always be 0. Okay, so the upper triangular matrix, this is the matrix. Let me make another matrix, upper triangular matrix. So first we'll make a diagonal. Let me take a matrix of 3 by 3. So I made a diagonal. Now you have to write here number 5, 6, 9, any number. Other values below this diagonal will be 0. So you have to put 8, minus 10, any number. Now again, the lower part should be 0. So I'm making a triangle, proper triangle here. This is the upper triangular matrix because all these triangle part has value and the lower all are 0. So upper, that is why we call it as upper triangular matrix. Now let me write it as a lower triangular matrix. Again, making the diagonal, I have to put some value in the diagonal and the lower part need to have some value. Above values are 0. That is minus 8, 5, 6, any random number I am taking, 2, 3, 7. And all others upper should be 0. So this is the triangle, lower triangular. All values are there. The above part is all 0. We call it as a lower triangular matrix. Determinants. Matrix and determinants are talked together. So we can find out the determinant of a matrix, that is the value of the matrix. So order 1 is that we have one row, one column. And then the order or the dimension is always written as n cross m. So you have n rows and m columns. When you say we have one row and one column, it is of order 1. Order 1. So what is the determinant of that matrix? When we talk about square matrix of order 2, it is 2 by 2. So when we take the order 1, that is just one value we have written. How many rows? 1 rows. How many columns? 1 column. So 1 row, 1 column, this is a square matrix of order 1. So when we take the determinant of this matrix, there will be no value other than 2. So the answer is 2. The determinant is 2. If I write a matrix like this 5, 6, 9, 3, how many rows are there? 2. How many columns are there? 2. 2 by 2. So this first one I'm saying order is 1 by 1, that is the order is 1. And what is the aij, that is the value inside. Since I is 1, j is 1, there will be only one value in order 1, a 1 1, and there will be only one element. So determinant of that matrix with 1 by 1 will be the same as the only element which it consists, because first one row one column, that means only one value we are talking about. So when we talk about square matrix of order 2, and then the determinant will be, see, so now this is order 2. So what we'll do is, if I write a matrix, let me show you the general symbols. One row, one column, one row, two rows and two column it is there. So this aij means ai is row, I is row and j is column. So this is a11, one row, one column. This is a, first row, second column. This is a21, so second row, first column, a21. A22, that is second row, second column. So this is the matrix A. Now when we try to find out the determinant, that is you multiply a11 with a22, and then subtract a21 into a12 from it. So a11 into a22 minus a21 into a12, this is going to be the determinant of order 2. Order 2. Let us take an example. This is the matrix. Now this is a 2 by 2 matrix. The order is 2. Order 1 we have seen only one element will be there. Order 2 we have this a. Now when we try to find out the determinant, you have to multiply 4 and 5, then subtract the multiplication of 2 and negative 3 with it. So negative 3. Okay. 5 4 is 20, negative will become positive, and 3 2s are 6. Or it will be 26. Okay. So this is 26. Now coming to the order 3. Order 3 I'm talking about. So I'll just change that order 2 to order 3. Now this is 3 by 3 matrix. I am talking about 3 row, 3 column. In 2 by 2, there will be 2 rows and 2 columns in a square matrix. 2 by 2 is 2 rows and 2 columns. That is order 2. But if I add 3, that is 3 rows and 3 columns, that will be called as order 3. And how to find out the determinant of order 3? So I'm just changing it to 3. How to find this? Now there will be simple way to understand that you can expand it using any row or any column. I'll give you an example here, then you better understand it. See, in 3 by 3 matrix, always we have 1 2 3, this is 3 rows and 3 columns. So whenever this a11 will come, what is this? 1 1. So 1 plus 1 is 2. So whenever we expand, minus 1 to the power I plus j, that sign will put. So, or to be very, in a very informal manner, whenever we expand it using any row or any column, the middle one has to be a negative. Middle one has to be negative. Okay, you will understand by this. I am opening it using the first row. You can use any row or any column in this matrix to open it. So I am using 2 3 minus 5 as the expanding row. You can use any row or any column. So you write 2 here. As I said, just use negative here. That is, the middle one has to be negative. Negative 3. I'll show what it is going to come here. Then we have negative 5. So put it like that. There is no sign change. Only the sign change will be the middle one. The 2 and minus 5 will remain like that. 3 has to become negative. Okay. Now you see what will come. Whenever you do this 2, find out 2. This 2 row, whichever row and column this 2 comes, you leave it. Other values you have to write. 1 4 negative 2 1. 1 negative 2 4 1. Similarly with 3. When you come to 3, hide that row and column which are intersecting at 3. So this row and this column you don't have to worry about. Other values which are left you have to write. So 7, negative 3, minus 2 and 1. right? Now, when you come to minus 5, the row and column intersecting with minus 5, you have to leave whatever is remaining 7, 1, negative 3, 4. Just write it here 7, 1, negative 3, 1, and 4. Okay, now you know how to find out the determinant of 2 by 2 matrix. 1 into 1 minus 4 into 2, 8. So plus will be there. So this is 2 was outside and this is 1 plus 8, that is 9. So you get 2 into 9 minus 3. Now 7 ones are 7 minus 3 2s are 6. Negative negative becomes positive. So 7 minus 6 is 1. Minus 5. 7 4s are 28 and minus or minus is plus 3. So it will be 31. So this is the final determinant value because we expanded it using first row. You can use any row or column to expand. Only the middle one has to be negative. Now the final value will be 18 minus 3 minus 31 into 5 is 155 and that is going to give you negative 140. If you use any row or column, the value will be same for that determinant. This is a 3 by 3 matrix determinant. Always remember the middle part has to be negative. Whenever we take the matrix and try to find out the determinant, so there are two main things, minors and the cofactors. So let us understand the minors first. And this is an example so that we can understand the minor. So whichever value you have to find out the minor, that row and column leave, whichever is remaining is your minor for 2 by 2. This is order 2 by 2 matrix, and in order to find out the minor, so let us say that we have this is as A11, A12 because we have two rows and two column in 2 by 2 matrix. So this is 2 A21 and A22. Okay. Now, in order to find out the minors of A11, then the first row and the first column, the values should not be taken, only the second row, second column. In A12, the intersection is first row and second column, so only A21 will be there. So A12 minor will be A21. Similarly, A21, so row and column intersection, only A12 is remaining. So A21, the minor will be A12. Similarly, A22, row and column if you leave, only A11 will remain. So this is, see, minus 1, it will be 3. For 4, it will be 2. For 2, it will be 4. And for 3, it will be negative 1. So these are the minors of 2 by 2. So in order to find out the minors of 3 by 3 or any matrix, so in order to find out determinant, you have to find out minor then cofactor. So let us take an example here and understand how do we find out the minors. In minors, we never talk about sign. What is plus, what is negative? No. We only talk about the values. The signs are talked when we are talking about cofactors. So there are certain values which you see here, but we'll try to find out the values. So one row I'll take and try to find out the minors. For example, A11 or 4 in this case example. So you have to leave that row and column where A11 intersection is there. So only A22, A23, A32, A33 will be there. For example, if you have A11 which is 4 in this example, then you have to take 0, 0, 3, 4. That is the row and column intersection. You don't have to take other values you have to take. Now find out the determinant. 4 into 0 is 0, 3 into 0 is 0, 0 minus 0 is 0. This is the minor of A11. Now let us take 7 here. That is, I am taking the value of A12. So we are finding out the minor of A12. That is 7. So row and column intersection of 7 needs to be left. Only the other values minus, this is negative 9, this is 2, 0 and 4. This needs to be taken. Okay, since this is determinant, so just multiply these two. Minus 9 into 4 minus 2 into 0. So this is going to be 9 4 is 36, negative 36, 2 into 0 will be 0. So it will be negative 36. Okay, we are going to use it. 8, how to find out? Because it is corresponding to A13. A13 is 8 here. Now row and column, just leave it here. If you are taking A13, this row and this column you have to leave. So A21, A22, A31, A32 only will be there in the determinant of 2 by 2. So you have to find out the minor of 8, leave all these, it will be negative 9, 2 and 0 and 3. Okay, multiply this. Minus determinant basically, minus 9 into 3, minus 2 into 0. So 9 3 is a 27, negative 27 it will be. Negative 27 and this is 0. So what we found out for the first row, I gave you an example. For 4, the minor is 0. For 7, the minor is negative 36. For 8, the minor is minus 27. And this can be done for each and every element in this matrix. Once we are done with the minor, then we have to find out the cofactor, and that will help us in finding the determinant. So the cofactor is nothing but minor with the sign, plus or minus. This is a 3 by 3 matrix. Every minor should be having the corresponding sign value. For example, if you just saw, we found out A11, the minor was, if you just remember, A11 was 0, A12 was negative 36, and A13 we found out the minor, it came to be minus 27, negative 27, if you remember. Now let's just give me some time to just give you a hint. So I'm just leaving this row and column, and for example, if I have to find out the, say, A12 minor have to be find out. What is the, how do we find out the minor? A12 was the row and column we have to leave wherever this A12 is intersecting. So what do we get? Minus 9, 2 and 0 and 4. I'm just giving you an idea about how to find out the minor. So minus 9 into 4, minus 2 into 0, 2 is, that will be 0. So minus 36. This is how A12 has come. Now we have to find out the cofactor. How to find out the cofactor? Just use the sign, and that will be negative 1 to the power of I plus j. This all is the minors. That is why I am writing m. Ij is the subscript. So now to find out cofactor, you have to put a sign here, and the sign will be negative 1 to the power of I plus j. Negative 1 to the power of I plus j, right? So I is what? 1, j is 1 here. In the second case, I is 1, j is 2. Here minus 1, I is 1, j is 3. So now this has become a cofactor. Let me tell you the property of negative 1. Negative 1 to the power of even will always be 1, and negative 1 to the power of odd is going to be always negative 1. So what this will be? Negative 1 to the power 1 plus 1, that is going to be 2. 2 is even, so it will be 1. Negative 1 to the power 2 is 1. 1 into 0 is 0. Now these are cofactors. Remember, minor with sign is cofactor. This is negative 1 to the power 3 and negative 36. And since this is odd will be, if you remember, it will be negative 1. Negative 1 into negative 36, that is going to be 36. Again, this is negative 1 to the power of 1 plus 3. So negative 1 raised 4 into minus 27. Negative 1 raised 4 is, because this is even, it will be 1. 1 into minus 27. This is going to be negative 27. So now the cofactor, see, the minor and cofactor are different. In minor we have negative 36, in cofactor we have 36. So this is how the negative 1 to the power I plus j has changed the minor to cofactor. So these are the other values of cofactor if you just want to try it. But we have taken the first row because we are going to find out the determinant of it. Minor along with sign is cofactor. Now using the minor and cofactor, how to find out the determinant? So the determinant, if this is the 3 by 3 column, you can use any row or any column to open it. So we will use this formula, but don't worry about the formula or the relationship. I'm going to give you an example and then we'll understand. This is always 1, 2, 3 because we can open it using any row or any column. So this is an example. If you remember, this 4, it was the minor was 0, 7 minor was negative 36, 8 the minor was negative 27. This was the minor. So let me just give you again a hint. How to find out the minor? In order to find out the minor of 8, just to recall, A13 minor will be M13. Just leave this row and column where this 8 is intersecting and take other values. So I'm leaving 478 and 804. I'm taking just negative 9, 0, 2 and 3. Okay. So this will be negative 9 into 3, that is negative 27, and minus 2 into 0 will be 0, so negative 27. So this is how we found out the minor. Now in order to find out the cofactor, what we did, minus 1 to the power of I plus j. I is 1, j is 3. So 1 plus 3, and this is minus 27. So this is going to be minus 1 to the power 4 is always even power of negative 1 will be 1, odd it will be negative 1. So what do you get here? Minus 1 to the power 4 is plus, plus into minus 1, minus 27 is minus 27. Now I'm going to expand it. Okay, right. So first row I'm going to take A11, A12, A13. So what we'll do, so please remember this also, A11 into the cofactor of 1, 1. Then A12, A12 into the cofactor of 7, basically A13, A12, and A13 multiplication cofactor of this one, A13. Now A11 is 4, A12 is 7, and A13 is 8. Now what about the cofactor? The sign will change. If you remember cofactor, when we found out the minor, then we found out the cofactor. The sign only changed. So 4 into the cofactor was 0, and here we have 36, and here it was minus 27. So when you compute this, the 4 into 0 is 0. So what 4 into 0 is 0, 7 into 36 plus 8 into minus 27. That is, you have to subtract these two. So let us take 7 into 36. 7 6 are 42, 2 4 carry, 7 3 is 21, 21 4 is 25. So 252 minus, now since my negative is there, so 27 into 8, 7 into 56, 6 5, 8 to the 16, 16 plus 5 is 21, 216. So 216. Now let us subtract these two, 252 and 216, it will be 12 minus 6 is 6, 4 minus 1 is 3, so you get 36. This is how my determinant can be found out using minors and cofactors. You can use any row and any column. We have just used the first row. There are multiple rows and 3 rows, 3 columns, whichever you want you can use, right? Like this middle one also. Just find out the cofactor, multiply by these values. Properties of determinants. So whenever we deal with matrix and try to find out the determinant, there are certain properties that these determinant or the matrix will follow. First thing is, the first property is that if you change or interchange the rows and columns, that is, if you take the transpose of the matrix, that is, if A is your matrix and change it to transpose rows and column, you just interchange this row to this column, this row to this column. Actually, it's just equivalent to the transpose. So this row, this column. The row and column interchange or column or row interchange will not change the final result. The determinant will remain same. Now the second property is, if any two rows or columns of the determinant we interchange, then the final determinant will have a negative sign, will have a minus sign. Okay. What does it mean is that you have a determinant, then how it will be negative when you change or change the position of two rows or two columns. That is, this is one row, okay, R1. So we have changed the position here. Now it has become row 2, and the row 2, this row has become the first row. So now you have changed the position. Now when you change the position, the determinant will simply, if the determinant is D, the resultant determinant of the interchange row or column will be negative D. One, if it is 5, it will be negative 5. So how do we change? See, this is R2, we interchange R2 with R1. If all the elements of a row is multiplied by some non-zero number k or lambda, that is a scalar, then the value of the new determinant will simply be k times the value of the original determinant. Okay, when you multiply this whole row is multiplied by k. So you just can take k common and you say that this is nothing but the actual determinant multiplied by k. So I'm just it can be column also. If I multiply this by say m, one column by m, so it is simply equal to m into the determinant. Determinant is simply of a1 b1 c1, a2 b2 c2, a3 b3 c3, right? Okay. Let me tell you an example here. For example, you have 2, 4, 8. The other elements can be anything. You understand by this. I can write 2 as 2 into 1, 4 as 2 into 2, 8 as 2 into 4. Okay. Now you have 2 common in all these. So what you can do is you can take 2 common outside. This is equivalent to k or m which I am talking about. You can take 2 outside. It will be 1, 2, 4. Inside this it can be anything, but what it is that this is a determinant and simply this is k into d, and where what is k here, it is 2. There is also a possibility to understand this, that you can have m multiplied inside and 1 by m outside, because ultimately 1 by m multiplied inside is going to cancel this out, or you can say m can be taken out and m by m will be 1. This is the same thing. So single row or single column multiplied by some scalar, it can be taken out and you say it is multiplied by the whole determinant. Very important property of the determinant is that if you have a summation, the second you see here, first column has a summation and second and third column remains the same. So you can write this matrix as two matrix as an addition. That is first three, that is a1 b1 c1 plus the x y z along with this b1 and c1 column. That is, we can combine these two. The right hand side matrix can be added and can be equated to the left hand side. This is one and the same thing, right? The value of the determinant is unchanged if any row or any column is multiplied by any number, any way you want. It doesn't matter. It's up to you to make the determinant simpler. For example, if I have this column a1, a2, a3, I've taken first column. Now, in some my thought I devised, I have to multiply this second column with m and then add it to the first column. So let us multiply each element of the second column by m and add it. So mb1 plus mb2 plus mb3. Now I think okay, more good option will be to subtract the n multiple of third column. So minus nc1 minus nc2 minus nc3. Whatever you want to do, it has to be applied to whole column or whole row. The determinant will not change. The value will not change, right? So this row, if I take this will be simply a3, a3, a3 everywhere. If any two rows of a determinant, they are same, they are identical, they are similar, then the determinant is going to be 0. For example, in this determinant, you see, I'll show you the actual property also for that. There is a byproduct of this property also. See, if you change the row 1, saying that row 1 should be replaced by row 1 minus row 3. Since row 1 and row 3 are same, a1 minus a1 is 0, b1 minus b1 is 0, and c1 minus c1 is 0. So I have just changed the row 1, so other rows will remain same. This all remains same. Okay. Now what are you going to get from here? If each element of a row or a column of a determinant is 0, then it is going to be 0. How it is going to be 0? See, these two properties are almost equivalent. Let us open this determinant by first row. So 0 into something will come. I'm not writing. Second is minus 0 into something will come. And the third plus 0 into something will come. Now you see here, I don't have to write anything inside because there is already 0 multiple. So everything will be 0. So if the row or a column of any matrix is 0, the determinant will be 0. This is equivalent to saying that if the two rows or two columns are equal, then we say that the determinant is 0. Okay. Now we have a diagonal matrix. What is a diagonal matrix? The element in the diagonal will have some value. The other values will always 0. So a11, a22, a33, a and n will be some value, others will be 0 when I is not equal to j. So this is a diagonal matrix. For example, I'm writing 2, 3, 2 and 0, 0, 0, 0. This is a diagonal matrix. So what will be the result of determinant? You can directly write 2 multiplied by 3 multiplied by 2. It will simply be 12. Row, or you can say column operations. What all operations can be done? Whatever I am talking about row can be applied on column also. So we have certain notation in order to evaluate a determinant. See, this is row 1, this is row 2, this is row 3. This is column 1, this is column 2, this one is column 3. Okay. Now, how do you represent a row? By Ri. I can be 1, 2, 3. For example, R2 I'm writing. Column can be Ci, it can be C1, C2, C3. So I'm writing C3, just for an example. Now, when we interchange any row or column, we use the double arrow and simply write Ri with double arrow and Rj. That is, we are replacing Ri with Rj. For example, I'm replacing R1 with R3. So I have to write R1 with R2 or R3, whichever you are changing. For example, column 2 and column 3 I'm interchanging. So C2, double arrow, C3. Now you want to change some row with certain calculation from some other row. How do we do this? For example, we want to change R1 such that R1 will be replaced by R1 plus some row, say R3 multiplied by 3. We multiply a whole row R3 by 3, then we add it to R1 and then we replace it to R1. Okay. So we are not changing any other row, only R1 will be changed. But this is how we are going to write. For example, column 2. So column 2 we are changing with, we just want to subtract C1 minus say C5, C3. So this is not valid, because in this change the column 2 should be there. So this is invalid. I hope you got the idea. C2 needs to be changed when C2 is applied with something, not C1 minus 5, C3. That is invalid. So this all notation is also valid for columns also. How do we evaluate the determinants? First thing is, if your determinant putting certain value, the value of the determinant becomes 0, then that value is the root or the factor of that determinant. Let us take an example here. For example, you have a determinant. You need to find out the determinant here. And there is a value x here. Now when you put x as 2 here, it will be 2. 2 square is 4. 2 cube is 8. Now other column I am writing just like that. 2, 4, 8. Okay. Now what do you get? There are two columns which are exactly similar. And when we know when the two rows or two columns are similar, that is, the determinant is 0. So putting x equals 2, the determinant has become 0. This means this x equals 2, or 2 you can take on the left hand side. So x minus 2 is a factor of determinant determinant, right? So whenever we use the determinant or expand the to find out the determinant, we have the sign system. And this sign system has come just with one interpretation, minus 1 to the power I plus j. I is the row, j is the column number. Since this matrix is simply row and column, so we have row and column. So we have to open, in order to find out determinant, with one row or one column. But when we open through one row or any column or any row, where will be positive, where will be negative? For example, A11 into something, it will be A22, A23, A32, A33. Then next second will be A12 and third will be A13. So something will come inside, for example. So what will be the sign in front of A11, A12, A13? These are the sign. So if I am opening with first row, plus minus plus will come. If I have opened this determinant using A21, A22, A23, then it would have been minus A21 plus A22 and minus A23. A21, next will be A22, third will be A23. Inside will be the minus, right? When we apply the cofactor, there will be sign, and this sign will be minus plus minus. Why? Because this sign has come from minus 1 to the power I plus j. What is I? I is row, j is column. Let us take this first one. I am taking A11. So 1, 1, 1 plus 1, I plus j is 1 plus 1, minus 1 to the power 2, that is going to be 1. Now A21, minus 1 to the power 2 is 2 plus 1 is 3, and minus 1 to the power 3, that is the odd number, is minus 1. That is why minus 1 has come. Let us take one more, A23. So 2, 3, this is minus 1 to the power 2 plus 3, that is I plus j. So 2 plus 3 is 5. Since it is odd, it is going to come negative. So in front of A23, you have to put a negative sign by yourself. That is actually equivalent to the cofactor. Cofactor is all about the sign, because the cofactor includes one is minor, and with sign the minor becomes cofactor, and that is what the sign is being shown here. Okay. So we have the determinant, or we need to compute the determinant, and this is an example here. So the first thing is, you will be tempted to do 42. You open with first row 7 3 4 2, then you put the sign minus, and then you put the value which are not in the intersection, that is 28 14 7 4 2. Then when you put 6, it will be 28 7 14 3. Okay, 28 7 4 3, right? But I am just saying that you don't have to do this, because most of the determinant, I must say majority of the determinant, there you can apply the property. For example, 42 can be written as 7 6 of 42, 28 is 7 4 to 28, and 14 is 7 into 2. Now you see how you devise the determinant. 6 4 2. Other things I'm writing. Now you know, if you have a single row or column multiplied by k, you can take k common from that, and that will be k into the final determinant. So what do you get? 6 4 2 1 7 3 and 6 4 2. But here you see two columns are exactly same. And as I described you, two columns same, that means the determinant will be 0. The determinant is 0. So you multiply 7 with 0. So it's going to be 0. So this is how we choose the property, so that we can calculate the determinant in a way that is easier, faster, and which is wanted by the examiner. Now we have an example here. So let us try something and let us see what happens. For example, you see I'm going to do, but it may or it may not work. So first thing is 1 1 1 A B C. You can make them into two separate matrix additions. So 1 A 1 1 1 A B C. Keep it like that. Now this B plus C, B C A can be written here, B C A, and C A B can be written here, C A B. Okay. Now, do you see anything common, or can you come up with certain solution which can say make it easier for you to complete the determinant? No, we're not getting any solution. So we'll try to apply some other property. So this didn't work, which I tried. So this is column 2 and column 3. Now when you add this column 2 and column 3, you will get A plus B plus C, and that A plus B plus C will be in all of the third column. So 1 1 1 ABC will be there. Now I am changing C3 with C3 plus C2. That is column 2, column 3 addition should be kept in column 3. So A plus B plus C, A plus B plus C, A plus B plus C. Now we are getting something. Now take this A plus B plus C common. So A plus B plus C common I am taking. You get 1 1 1 A B C and 1 1 1. Now you have two rows, or you can say two columns, which are equivalent. They are same. That means the determinant is 0. The determinant becomes 0. Okay. So this is A plus B plus C into 0. So this is how we find out the determinant, and this, using the property, it makes it very easy to comprehend and to solve. Applications of determinants. Area of a triangle. Now, determinants can be used in multiple actual life scenarios. Whenever we learn mathematics, it's not just for our logic testing or reasoning, it's to apply it to the real life. For example, one example we are going to see where we can apply the matrix or the determinant in the area of triangle calculation. For example, this triangle has the vertices as x1 1 1, x1 y1, x2 y2, x3 y3. So the determinant can be written as half. Now you take the first coordinate, that is the x coordinate, x1 x2 x3, write it here, x1 x2 x3. Now you take the second coordinate, that is y1 y2 y3. Now you write 1 1 1 1 1 1 here, and this is going to be the determinant. That is, how are you going to write? You just have to expand this determinant, and we will expand it using the column first column, that is this column. Okay, half will write later, x1 into what will be there, y2 y3 1 1, and minus x2, you get y1 1 and y3 1. This is not x1, I'll just change it. This is y1 y3 and 1 1 plus x3, and whichever is the intersection, we leave that, and those number in the intersection, others we use. So y1 y2 1 1. So you have this y1 and y3. Okay, now this is x1 and y2 minus y3. This is simply 2 by 2 determinant I am taking. Y2 minus 3 minus x2. This is y1 minus y3. Y1 minus y3. Then we have x3. This is y1 minus y2. Okay. Now you can just replace this. We don't want the negative sign in between. So if I replace it by plus, this becomes y3 minus y1. Okay. So the result will be like this. And you just take this and divide by 2. You get the final answer. Area of a triangle. Now we have an example here. So the vertices of this vertex, 3 vertex are given. So how do we find out the solution? Let us take the 3 vertex and we will try to find out the determinant of it. But there is a special way of writing it. This is x1 y1 negative 1 8. This is x2 y2, which is negative 2 and negative 3. And then we have x3 y3, 3 and 2. Now you can take any one x1 and y1. You can take even this 3 and 2 x1 y1. You can take my negative 2 negative 3 as x1 y1, and it will not change the result. So how do we write it? I'll write each and everything. So the formula is half. Now you take all the x coordinate. So we write x1 x2 and x3. Then we write the y coordinate, y1 y2 y3. Then we write 1 1 1. This is the final formula of the area of triangle. If the vertex or 3 vertices are given. So let me just show you that this will be the answer, and how does it come? I'll just show you. So this is half. Now you see, I'll take all the x coordinate, negative 1, negative 2 and 3. So negative 1, negative 2, negative 3, x1, x2, x3. Then we have y1, y2 and y3. What are these values? It's 8, negative 3 and 2. Then 1 1 1. So we'll talk about half later, but we will expand this. With the first row, you can use any row or any column. I'm expanding it using the first row. So let us see what we get. So I'm just changing the color so that this minus 1, then we have row and column of minus 1 has to be left. Others need to be written. Negative 2, negative 3, negative 3, 2, then minus 8. Then it gets minus 2, 3 and 1, 1. Then we have this 1. So you have plus 1. And then we have to write negative 2, negative 3, 3 and 2. Okay. So this is negative 2 and minus 3. So I'm finding out the 2 by 2 determinant. Minus 1 into minus 5 it will be. Now negative 8. So this will be negative 2 into 1 minus 3 into 1. So negative 5 it will be. Negative 5. Okay. Plus 1. Then you have 2 into 2, 4. So negative 4 minus. Minus or minus is plus. So 3 is a 9. Okay. So you get 5 here. You get 5 is a 40. It will be plus 40. Then you have 9 minus 4. That is 5. So plus 5. So 40 plus 5 is going to be 50. Now you already had half here. So half into 50, that is 25. So since the unit is not given, so you can just write 25 square units. This is how area of triangle is formed. Now if you have a triangle, there will be some area. But if the area is 0, what does you comprehend? That means only one thing, that is a single line, the area is 0. So area of triangle, if it comes, then there will be area of triangle. But if the area of triangle is coming as 0, then we can easily say that the 3 points, if we are talking about 3 points, they are collinear. Collinear means co-linear. Co means together, linear means are on the same line. So these 3 points are on the same line. So how do we use the determinant or matrix logic inside this? Because we know the area of triangle is x1, y1, x2, y2, x3, y3. If these are the different vertex, so area of triangle is given by this relationship and it has to be 0. So the condition of collinearity of 3 points, the example will be like this. We need to find out x using the determinants. So if we have 3 points and if they are collinear, that simply means the area of the triangle formed by these 3 points should be 0. So we'll take these 3 points, find out the area of the triangle and put it equal to 0. And then this way we can find out the value of x. For which value of x? The area of triangle will be 0. Because in terms of determinant, we know the formula of, or we have devised a formula of finding the area of a triangle. Okay. So just see here. This is the area of a triangle. Half. I'm taking the x coordinates. So x, 5 and 8. We have x, 5, x, 5 and 8. Then we'll take the y values. So x1, x1, x2, x3, y1, y2, y3, 1, 1, 1. This is what I'm going to write. I'm writing actually. So triangle area will be 0 because they are collinear. So half into x5, 8. This is under the determinant. Then the negative 2, 2 and 8. These are the y coordinate. 1, 1, 1. And we'll compute this and equate it to 0. Half will not be used because half is a scalar. It is a constant value. It cannot be 0. We expand it using the first row. X inside this will come 2, 8, 1, 1. Then you have negative 2. So 9 minus minus is plus 2. Leave the row and column for minus 2. 5, 8, 1, 1 will come. Now we have 1 here. So we get 5, 8, 2, 8. 5, 8, 2, 8. Okay. So now x 2 minus 8. What is 2 minus 8? Negative 6. Then you have 2. 5 minus 8 is negative 3. Then you have 5 is a 40. 40 minus 8 to the 16. That is going to be 24. Okay. You have negative 6x minus 3 to the 6 plus 24 equals 0. I'm taking 6x on another side. 6x will be 24 minus 6. That is going to be 18. And 6x equals 18. Divide both sides by 6. You get x as 3. So x is 3 and for x equal to 3, these points will be collinear. So this is how you have to do. Exactly I have done same way. So this is how you can find out the condition. Solution of system of two linear equation. We are using the Kramer's rule. So Kramer rule, that is we are using determinant to find out the value of the linear equation. Please understand, linear equation is nothing but an equation with not more than power of 1. X square, it will be, say, um, x cube and x to the power 4. All these will be polynomials. So linear we are talking about. X. So we are just having x and y values here, that is the variables. Other are constant value. So these are nothing but lines. So if you want to find out directly the value of x and y using the Kramer rule, you can find out. There are different ways of solving the linear equation, but this is one of the way of solving the linear equation using the Kramer's rule. So how do we write it? I am writing the left hand side a1 b1 a2 b2. I am also writing c1 and c2. Why I am writing all of it? Because I just want to tell you that with this equation in your mind, actually a1 b1 a1 b1 a2 c2 is equal to c1 c2. So determinant d will be equal to the left hand side part, that is a1 b1 a2 b2. This is clear? D. Now when you try to find out d1, you are actually targeting x. So in place of a1 a2, you are going to replace c1 c2. That is, in a1 a2 b1 b2, a1 a2 has to be replaced by c1 c2, b1 b2 remains the same. This is d1. How about d2? d2 is what? In place of y, because you are targeting y here. So in place of b1 b2, you are going to replace c1 by c1 and c2. a1 a2 remains the same. Now you have to replace c1 and c2 here. So c1 by c1 and c2. So this, when you found out, you can easily find out the determinant is 2 by 2. So x can be found out directly using d1 by d. Y can be found out using d2 by d, right? But this d1, d2, d, these all can have certain values. So this values will, see, this actually, d is actually this. First, you cannot, the d can be 0 also. So if d is 0, it is how it is defined or how it is not defined. I'll tell you the whole scenario. That is, in the same discussion, if the determinant is not equal to 0, that is, if you find out x, it will be d1 by d, x y is d2 by d. So if d is not equal to 0, that means you are going to get consistent and unique solution. As I previously said, that linear equations are just line. They are line, ax plus by plus c form. So you will get a consistent and unique solution because the two lines are going to intersect. So you'll get some point. But if in case all of them are 0, d is 0 and even d2 are also 0. That is, it is 0 by 0, 0 by 0, x and y. But this means the system still remains consistent, but it has infinitely many solutions. Now you'll ask the question, how? As I just said, that if you have two lines and they intersect, you get a proper point. That is the case when d is not equal to 0. This is the case when d is not equal to 0. Line 1, line 2, they are intersecting. So you get a proper point of intersection. That is the solution of these two equations. But when you have these two lines and they both lines are equal, they both lines are same, then the system will be consistent and infinitely many solutions. What about d equals 0 and d1 d2 not equal to 0? That is, if you have d0, that is, you are dividing by 0, and as I said, dividing by 0 is incomprehensible. For two lines intersecting at one point, you get a proper solution. If both are, everything is 0, consistent infinity many solution because they are same line. But if you have two lines which are in different plane, they are not going to intersect anywhere. That is, it is inconsistent and it will have no solution. Now let us take an example of this Kramer rule of two set of linear equation. We have this 2x minus 3y equals 7, and we have 3x plus y equals 5. So we have two equations here, and these are nothing but two lines. They are representing two lines. So how they are going to intersect, this will describe the result of the solution. It may describe the proper point, or it may also say that both the lines are same because they both represent the same thing. So you have infinitely many solutions. So first we'll find out the d. What is d? D is on the left hand side, whichever is there, write it here in the form of determinant. So 2, 3 and negative 3 and y. I am writing the coefficient of x and y. So now find out the determinant. 2 minus minus of this is plus of 3 is 9. 9 plus 2 is 11. So d is not equal to 0 in this case. Now let us take d1. d1 will be what? It will be replace 2 and 3 by 7 by 5. 7 and 5. So 7 and 5 in place of 2 and 3. We have negative 3 and 1. So what do you get? So I am, as I said, this d first column has to replace by 7 by 5. 7 minus the 7 minus 3 5 is 15 plus becomes, so it becomes 22. 17 and 5 is 15 and 7 is 22. Now d1 is not equal to 0. Coming to d3. d3 now you have to replace negative 3 and 1 by 7 and 5. So 2 3 remains here. Now this has to be replaced here, 7 by 7 and 5 here. So what do you get? A1 A2 C1 C2 this is. Okay. So this is A1 A2 B1 B2 and this is C1 C2. So what do you get? 5 2 is 10 minus 7 3 is 21. You get negative 11. Okay. So neither of them are 0. So x will be d1 by d, y will be d2 by d. So d1 is what? 22. D is what? 11. What is d2? It's negative 11. And you have this one as 11. So you get 2 here, you get negative 1 here. So when you solve this by Kramer's rule, x becomes 2, y becomes negative 1. Okay? Kramer rule, that is in order to find out the variable, 3 linear equations, that is you have 3 lines. Now 3 lines can intersect, 3 line can be same or 3 line can be in different plane. So you have different way of comprehending. So this is our first linear equation, a1x plus b1y plus c1z equals d1. There are other lines also. So there are 3 lines actually here. Now all a1 till d1 they are constant, x y z are variable. So we need to find out x y z. In the two system of 2 linear equation, it was just x and y. Here we have x, y and z. X will be d1 by d, y will be d2 by d, and z will be d3 by d. And what is determinant? What is d here? Whatever is in the left hand side, all the coefficient you have to write. That is a simple way of writing it. So this is the whole matrix, or you can say the determinant of this matrix, that will be d. So I am writing d, and I'll tell you how to write d1 d2 d3. So I am writing a1 a2 a3 b1 b2 b3 and c1 c2 c3. This is what? This is your actual determinant d. Now in order to find out d1, just replace the first column by the right hand side. That is d1 d2 d3 has to be placed in a1 a2 a3. So d1 d2 d3, you have b1 b2 b3, and you have c1 c2 c3. This is your d1. Same way we can also find out d2. What is d2? The second column has to be replaced by, because we are targeting y here, just replace b1 b2 b3 by d1 d2 d3. Other things remains the same. For example, a1 a2 a3 will remain there, c1 c2 c3 will remain there. Only the middle one, which is b1 b2 b3, has to be replaced by d1 till d3. Now same thing we have to do for d3 also. That is, in d we are targeting now the z. d3 will be used for z. So a1 a2 a3 b1 b2 b3 remains same here, but the third column has to be replaced by d1 d2 d3. I hope you got the idea. So this is x d1 by d, y will be d2 by d, and z will be d3 by d. So this is how all values can be computed. But there can be various scenarios. What can be the scenarios? If the determinant is not equal to 0. Because if 3 lines are intersecting, that means if d is not equal to 0, you will get some proper solution, or 3 intersection or 3 lines intersecting at a common point, and that point will be the actual solution, and that is going to give you a point in 3D plane. X is d1 by d, y is d2 by d, and z is d3 by d. So you'll get a consistent and a unique solution. What about when all of them are 0? D also 0, d1, d2, d3 also 0. So that means all these three lines are same. So when the lines are same, that means they are not intersecting. Actually, they are intersecting in infinitely many points because all the three lines are same. For example, x plus y plus z equals 3, and so 2x plus 2y plus 2z equals 6. They both are same. And third condition, if we have multiple condition inside this also, if the determinant is 0 and one of these d1, d2, d3 is not equal to 0, then the system is inconsistent and it has no solution. Okay, one of this is not equal to 0 because d is 0. That means in the below part, or the say denominator part is 0, that is it will make it inconsistent. If d1, d2, d3 is equal to 0, then we call them as a homogeneous linear equation. If the determinant d1, d2, d3 is equal to 0, then this is homogeneous linear equation. In this case, if d1, d2, d3 is 0 and determinant d is not equal to 0, then the system has very simple and trivial solution, that is all x and y and z are, and all those three are 0, because d is not equal to 0 but d1, d2, d3 is 0. Okay, so d1, d2, d3, if they all are 0 and the determinant is not 0, we have a traditional trivial solution, x, y, z equals 0. But if d1, d2, d3 equals 0 and d is equal to 0, we have already seen in the second part, the second point you see, it will have infinite many solution because all the three lines are same. Let us take an example of this three linear equation. So we'll use the Kramer rule. We have these three equation, and these three are equation of line in 3D plane. So let me tell you, first thing you have to write is d, and d will be all the values on the left hand side, right, in the form of matrix or determinant form. So 5 to 5 coefficient of x, -1 3 -2 coefficient of y, 4 5 6 coefficient of z. Okay, d you found. I hope you'll be able to find out the determinant of this value. We have already done discussing this. So say it is 51, not equal to 0. Now in place of 5 to 5, replace it with whatever is on the right hand side, 5 to -1. So 5 to -1 we are writing here. Other things remain same in the d. You'll get a determinant which we call as d1. d2 is what? The middle one, because we are targeting y here. So this one, -1 3 -2, has to be replaced by 5 to -1, and again the determinant has to be found out. So what do you get here? 102, say. Now d3 is the 4 5 6 has to be replaced by 5 to -1. Okay, one by one, replace first column, second column, and third column by 5 to -1, and this is how you get d1, d2, d3. So let us say it comes as -102. And what is the x is d1 by d, y is d2 by d, and z is d3 by d. Okay, so this is by Kramer rule. You get x as 3, y as 2, and z as -2. Please remember, d is not equal to 0, then we found the solution. Otherwise, other options will come, other scenarios will come. Okay, this is all about this discussion. Thank you so much. Take care of yourself.